Hello and welcome to another episode of the Williams Learning Lab. In this episode we are talking about atomic structure and we're going to learn how to draw Lewis structures by using the Octet Rule. The method that we're going to use, we're not calculating formal charges or counting the total number of valence electrons. What we'll be doing is looking at the number of unpaired electrons in the electron dot structure so we can determine how it's going to connect with other atoms. We're going to do 4 examples. We're going to do HBr, hydrogen bromide, H2O, water, NH3, ammonia, and CH₂O, formaldehyde. And by the time you're done, you should be able on your own to draw some structures such as these. Okay? You're going to need a periodic table, and the reason why you're going to need that is so you can draw the number of valence electrons, and you're going to need to determine how many valence electrons from that periodic table. If you don't know the trick, usually, they're not always this, but you can assume that the transition metals are 2. Check with your instructor. Your lanthanides and actinides, you can assume that they're 2. Check with your instructor, but those don't really follow this pattern because they do some exceptional things. Group 1 are going to have 1 valence electron. Group 2 are going to have 2 valence electrons. Group 13 are going to have 3 valence electrons. Group 14 is going to have 4, Group 15 is going to have 5, Group 16 is going to have 6, Group 17 is going to have 7, Group 18 is going to have 8 valence electrons, except for helium, it has 2. So the pattern goes 1, 2, 3, 4, 5, 6, 7, 8, except for helium, it has 2. All right. Lewis structures are a way to show how atoms are bonded together while displaying their valence electrons. Lewis structures are used to predict molecular shapes, reactivity, and bonding patterns. You will need a periodic table to determine the number of valence electrons. This method works with using the Octet Rule. The Octet Rule states that atoms tend to bond in such a way that they have 8 valence electrons. There are exceptions to the Octet Rule, but will require tracking formal charges, and we're just not doing that today, okay? And so in general, got 4 steps for you for how to draw Lewis structures. Step 1, identify the least electronegative atom as the central atom. Hydrogen, however, is always on the outside. Step 2, determine the number of valence electrons of each atom. Each unpaired electron will form a bond. Step 3, shared electrons will be drawn as a dash to represent a bond. Lone pair electrons will be represented as dots. Step 4, count the number of electrons for each atom to ensure the Octet Rule is satisfied. All right. Let's do our first example of hydrogen bromide. All right. For our step 1, we do not have to determine which one is the central atom because there's only 2 atoms in hydrogen bromide. All right. So let's look at hydrogen. On the periodic table, it's in group 1, so that means it's going to have 1 valence electron. So its electron dot notation is going to be that right there. Hydrogen with 1 valence electron. Our bromine, it is a group 17 element, so it's going to have 7 valence electrons. So let's put in our valence electrons. 1, 2, 3, 4. Remember not to pair until the 5th one. 5, 6, 7. Okay. Now I look at how many unpaired electrons does each atom have. Okay. Hydrogen has 1 valence electron. Hydrogen is an exception to the Octet Rule. It is satisfied with 2 because it's so tiny. Bromine has 1 unpaired valence electron. It needs 1 more, so they are going to share those atoms in a covalent bond. So I'm going to draw my electron dot structure here. And I'm just going to have the 2 atoms side by side with that shared electron between them. Now the Lewis structure, so now I'm going to draw it. And I'm going to represent those shared electrons as a dash. And now I'm going to put my lone pair electrons that are on the outside of bromine, not participating in a bond on the outside. Okay? Because that can be important sometimes. All right, so right now we have the Lewis structure of hydrogen bromide. Let's do another example. This is a very important example. And so now we have H₂O water. So hydrogen, just as we saw, it has one valence electron because it's a group 1 element. So I'm going to put that there. And for oxygen, oxygen is in group 16. So it's going to have 6 valence electrons. 1, 2, 3, 4, 5, 6. And so I'm going to review it now, and I'm going to see how many unpaired electrons does each atom have. Hydrogen has 1 unpaired electron, so it can make 1 bond. Oxygen has 2 unpaired electrons. Each of those are going to need to make a bond. Well, lo and behold, oxygen needs 2 bonds, and we have 2 hydrogens that each make 1 bond. We do have a central atom here, and since hydrogen is always on the outside, oxygen is going to be our central atom. So I'm just going to draw it right here. I like to draw my electron dot structures first. And then I am going to put each of my 2 hydrogens that I need right beside oxygen's unpaired valence electron. So now we're going to have a bond there. I'm going to put hydrogen right here. And so now I'm going to have another bond. I am going to rewrite my Lewis dot structure just by having the bonded electrons drawn together as a line. So here are my electrons for my oxygen that are not participating in bonds. Well, I didn't use blue like that, but it'll be okay. We'll just use black. All right, and so right here we have hydrogen bonded with oxygen 2 times. So let's just double check to make sure, since this one's a little bit more complicated, that we have enough electrons. Every dash represents 2 electrons, so we have 2, 4, 5, 6, 7, 8. So oxygen has 8 valence electrons now with this sharing going on, and hydrogen's got 2, and this hydrogen has 2. So now we have fulfilled the octet rule, and this is the Lewis structure of H₂O, water. All right, let's do a couple more examples. If you have any questions, please leave them in the comment section below, or if there's an example that you would like to see, or you'd like to see me do some examples of calculating the number of electrons in the molecule and using that to find some more complicated Lewis structures. So if you're interested in that, please put it down below. So next we're going to do NH3. This is ammonia. All right, so hydrogen. It has 1 valence electron, so its electron dot is here. Let's step back real quick. Let's determine what our central atom is going to be. Well, we have hydrogen and nitrogen. Hydrogen is always on the outside, so nitrogen is going to be the central atom. And as you start getting experience with doing these, you'll start to be able to maybe even skip some steps and just go straight to the Lewis structure. But I think this is a good method to learn. Nitrogen, it is in group 15, so it's going to have 5 valence electrons. 1, 2, 3, 4, 5 valence electrons. And so we see here that we have 1, 2, 3 electrons that are not in pairs. And so those electrons are going to want to connect with other atoms to form a pair. Well, since nitrogen needs 3 other atoms to share at least 1 electron, we can see that a hydrogen can do that. And because our molecular formula says we have 3 hydrogens, we're going to have 1 on each of those sides. So I'm going to go ahead and draw my central atom again. and putting its valence electrons around it. And now I'm going to insert a hydrogen in each location where there is an unpaired electron on nitrogen. So that would technically be the electron dot structure of ammonia. And so all we have to do now is draw this structure again, but every bond is going to have a dash. So there will be my 3 bonds. And this is the Lewis structure of ammonia, NH3. Let's count the number of valence electrons, make sure we're good. So there is a bond right here, so that's 2 electrons. Hydrogen's happy. There's another bond here, so this hydrogen's happy, it's got 2 electrons. There's another bond here, so hydrogen's happy, it's got 2 electrons. So let's see what nitrogen's up to. We have 1, 2 electrons, 3, 4, 5, 6, 7, 8. So nitrogen has fulfilled its octet rule. Alright, so next one, I usually get a lot of questions on this one in class. And so draw the Lewis structure of CH₂O. This is also known as formaldehyde. So you look at your periodic table and we're going to determine which of these atoms is going to have the least electronegativity. So the more to the left you go and the more down you go, the more, excuse me, I said that backwards. Please listen carefully. We're going to find which one has the least electronegativity. As you go up and to the right, you have more electronegativity. So the lesser electronegativity is going to go to the left and down. So the one that is most left is carbon, so we know that's going to be our central atom. Let's go ahead and determine the number of valence electrons of carbon. Carbon is in group 14, so it's going to have 4 valence electrons. Okay, we're going to put 1 on all 4 sides because they don't pair until the 5th one. And we can see that that's going to have 4 bonds because it has 4 unpaired electrons. So next, let's do hydrogen. Hydrogen, we've been doing this one a lot. It has 1 valence electron, and that's going to be its electron dot notation. And for oxygen, we've done this one before. It is a group 16, so it has 6 valence electrons. 1, 2, 3, 4, 5, and 6. So let's kind of analyze this. Carbon needs to have 4 bonds. We look at hydrogen, in the molecular formula, there's 2 of them. So we know that 2 of those bonds are going to be connected to carbon, right? Because carbon is the least electronegative atom that is not hydrogen, so it's in the center. So 2 of those bonds is going to be to carbon. So if we use 2 bonds to take care of 2 of those unpaired electrons, that means carbon will have 2 more unpaired electrons that needs to connect to. Well, lo and behold, look at oxygen over here. It has 2 unpaired electrons. So these 2 unpaired electrons can pair with both of the remaining carbon unpaired electrons, and so that'll be a double bond. So I'm going to draw a line right here, and I'm going to do the electron dot notation on the left side. So as you do more of these, you'll gain a little bit more experience. And so what I'm going to do is I'm going to put 2 of my electrons on the side, and I'm going to draw my hydrogens here. So I have a single bond for both of those. Well, for oxygen, oxygen is going to have 2 unpaired electrons that need to bond. Well, it's going to bond with our carbon. All right, these double bonds get a little messy when you do the electron dot notation, but it's going to look something like that. So now we can take this information and apply it to a Lewis structure, because remember, this is the electron dot structure. And so let's draw what that's going to look like. Okay, and we have our oxygen up here. Just going to put the electrons on the side right there. Going to have a double bond here, and then carbon on both sides is going to have a single bond to the hydrogens. So now we have represented the bonds as dashes and the electrons as dots. So let's count the number of valence electrons everything has. Okay, we'll start with carbon. Carbon has 1, 2, 3, 4 bonds. Each of those bonds represent 2 electrons, so 2, 4, 6, 8. The octet rule has been satisfied. Hydrogen wants a total of 2 electrons, and it's got 1 bond, so it's 2 electrons here. This hydrogen has 1 bond, so it has its 2 electrons. So let's check oxygen. Oxygen has 1, 2, 3, 4 electrons on the outside, and another 3, 4, 5, 6. See, 2. I'm sorry, I miscounted there. Each bond has 2 electrons, so we'll have 1, 2, 3, 4 in the bonds, and then 5, 6, 7, 8 lone pair electrons on the outside. Sorry about that misspeaking right there. Anyway, guys, I hope you found value in this episode. All right. If you have any questions, would you please consider commenting, and subscribing? Questions, put that in the comment section below is what I meant to say. Until next time, guys, thank you for watching and keep on learning. Bye.